Okay, hi everybody. Thank you so much for coming. My name is Matt Adams. I'm with Passive Buildings Canada. Really appreciate everybody coming today, Wednesday afternoon, and we've had a lot of interest towards this event. So please mute your mic if you're not speaking, and we'll have a short presentation, and then we'll have questions, but we'll ask people to put questions into the chat to try to handle the number of folks. Just quickly, for people that might not be familiar with Passive Buildings Canada, we, for over 10 years, we've been supporting and building the broad passive house community through peer learning, public education, industry events, and more. Some of you might have attended our high performance design meets boots on the ground events, which we've done in different parts of the country and had planned to do in many more parts of the country before COVID, and hope to return to that, of course. There we bring together designers and builders and tradesfolks and engineers and homeowners to share and learn together, because that's the big focus of Passive Buildings Canada. We welcome a diversity of approaches and voices to connect and share knowledge and promote passive house projects, regardless of kind of the path you take or the angle you bring to it. But we're a not-for-profit, and our work is possible through the support we get from members. Mike, could you throw that little member slide up? I'm not going to go through this list, but just encourage you to go to Passive Buildings Canada and look at membership perks, because membership helps us do what we're going to do. And then in return, we provide free events and access to our legendary discussion listserv and board. It's a really good and built community that's growing and building, and it'd be great to have people, if you're not members, become members. Last year, for the first time, we are dipping our toe into research. PBC members, Builders for Climate Action / Endeavor Center approached us about partnering on this exciting research project in embodied carbon. And we were very excited to receive support from the Atmospheric Fund for this project. And we're really excited for it to be happening. We think it's very important. And today, Chris Magwood from Builders for Climate Action is going to be presenting and then taking your questions. So I hand it over to you, Chris. Thanks.
Okay, thanks, Matt, for the introduction. And yeah, I'm really excited that we are going to be able to work on this project together. Oops, I'll go back to the start of my slideshow. Yeah, really glad to be working on this project. Thanks for introducing Passive Buildings Canada. That was on my my list of things to do, to talk about the partners who are involved here. So Passive Buildings Canada, you just got introduced to via Matt. Builders for Climate Action is a relatively new organization. We're actually a project of the Endeavor Center, which is a not-for-profit sustainable building school in Peterborough. And our own sort of internal focus on the carbon footprint of the materials that we were using and the buildings we were making has kind of led us to realize that lots of people are interested in this, both practitioners and policymakers. And so we have been undertaking both quite a bit of research and some tool building, and now this project that is being sponsored by the Atmospheric Fund. And we're really excited to, beyond these three partners, we've had a lot of early support from municipalities within the GTHA, from the builder and designer and developer community, and really looking forward to sharing with you what it is we're going to be doing and how we're going to do it. So to kind of set the stage, what we're looking at in this study is the cradle-to-gate emissions of building materials for Part 9 buildings in the Greater Toronto and Hamilton area. And the reason that we're focusing on the cradle-to-gate emissions, so this is the emissions associated with extracting raw materials to make building products out of, transporting them to factories, and actually turning them into building products. So in life cycle assessment, this is stages A1 to A3, but cradle to gate is kind of the more common terminology for that. And we're focusing our attention here because for the vast majority of building materials, this is the majority of the emissions that they are going to be responsible for over their life cycle. So while we do, appreciate and think about the importance of end of life for a lot of these materials, it's between 70 and 80% of a material's life cycle emissions are happening in this phase. And this is also the phase that is sort of the easiest one for us to study, because the numbers here are the most certain numbers that we have. It's very easy for manufacturers to have an environmental product declaration made. It's verified by a third party, and they can trace their entire supply chain to the point where the product is ready to ship out. And so the methodology for doing that and the certainty in those numbers is the highest, and it represents this very large percentage of a building's life cycle emissions. And as practitioners, we can actually make a difference here in a really meaningful way. So the reason that we think that this is an important thing to study is that we already know from a number of studies that have been done that a typical residential building in North America has somewhere around 300 kilograms per meter squared of emissions associated with making the materials for that building. So the number 290, that's an average of a study that I did last year, and that the Carbon Leadership Forum and the International Energy Association have all done some benchmarking studies, and in their residential categories, this was sort of the average. So if we think about there being about 89,000 single detached homes being built in Canada every year, and that those homes are about 185 square meters each, that means that just the emissions from the materials from just that one type of residential building is approaching 5 million tons of emissions. So that's the equivalent of 1 million cars on the road for a year, or the emissions of 10 coal plants. And we know from here in Ontario, when Ontario closed its 6 coal plants, that was the biggest reduction in emissions in North America to date. And here we are in the residential building sector, able to make a bigger difference than that on an annual basis. So from the rough numbers that we have, we know that this is important, and that's why we proposed this study. So what we're going to do is, first of all, get some accurate figures using actual house plans from Part 9 buildings in the GTHA, and apply the same methodology to assessing the carbon footprint of them. So we have this rough number of 290 kilograms of emissions per meter squared of building area. What we want to find out is really, if we do this accurately and on real buildings and in this area, what do we see as that carbon footprint? We want to know for this region how many Part 9 buildings are built. So we know there's about that many single detached homes built in Canada, but how many buildings that fall into Part 9, which would include single family homes, duplexes, triplexes, row houses, townhouses, and even some small MURBs. How many of those are made here? And then figure out, the sizes of them based on real plans, so that we can really nail down in the GTHA what is the scale of the emissions from these building materials. And then what we want to do is be able to identify what are the high impact materials. So once we know what the emissions of all of these buildings in the GTHA look like, which are the materials that are contributing highly to that, what are the impacts of swapping out materials, and what sorts of design changes to those buildings might also result in some emission savings. And the graphic on screen right now is from the study I did a couple years ago, where I applied to the exact same building model a whole series of different materials so that the building performed the same, met code in the same way, but as you can see, would have very different emissions profiles depending on the types of materials we use. So what we want to do is know what GTHA Part 9 buildings look like now and how we might be able to adjust the materials and the designs of those buildings to make the numbers better. Once we've identified the sort of average emissions in the GTHA, what we want to do is figure out what's an achievable level of emissions and then work towards identifying policy options that would encourage those emission reductions. So the graphic you're seeing on the screen right now is from a very small study that we did for Duro-Dummer Township, which is just outside of Peterborough, where we modeled several residential buildings that were built there in the last couple of years, and saw that that the average result for the homes that were being built in Duro-Dummer was about 300 kilograms of emissions, which tracks pretty closely to the average number that I showed you earlier. And with a group of stakeholders in the building industry in that area, we came up with a threshold of 75 kilograms per square meter that they all thought was very affordable and achievable, and something that they would be willing to be able to do. And so in Duro-Dummer, they have the very first incentive program to actually reward people for meeting a threshold like that. So we don't know if that will be the threshold or if this will be the results from the GTHA study, but this is sort of the idea of what we'd like to try to put forward. And so our plan for doing that looks like this. We need to get the building data and statistics from Part 9 buildings across the whole GTHA. We're going to then collect building plans from builders and developers that sort of match the profile of those buildings. So if 50% of the buildings were single family homes and 20% were row houses, however it pans out, we'll get that number of plans that reflect the type of building and the square footage that matches that average. We will generate reports on all of those individual buildings using our beam calculator tool. And then from those results, we'll be able to analyze the results in the way that I just described. So looking at averages, means, high, low, and then starting to think about how policy, how building design, and how material selection could alter that scenario in our final report. So the methodology that we'll be using is our beam calculator, which is something that we have been developing over the past year. And we are developing it both for Builders for Climate Action, but also for NRCan. And so the beam calculator is a pretty straightforward way of looking at buildings' material emissions. You put in sort of the key dimensions for your building that you're studying. And essentially you can see by category of the area of the building. So here you're looking at the exterior walls, the cavity insulation portion, and the carbon footprint of all the materials is there to match the R value and the size of the building. And you can simply select the material that was used in that building. And once you go through all the levels of the building, you'll have a total carbon footprint for the entire project. So this will be the first time that a benchmarking study has been done anywhere in the world where we're actually using the same methodology on all of the buildings. The few previous attempts at doing benchmark studies, the studies have looked at results from people using all kinds of different software, looking at different phases of the building. So it's been difficult to sort of say, well, this is what the material emissions look like, but by using this methodology for all the buildings in this study, we'll be able to make a really good description of what the current scenario looks like. And then we can also use BEAM to put in different materials to those same building models to look at what the results will be from material swapping. And just as an example, as we were developing BEAM, we used it with Trent University to help them develop a new classroom facility on their campus. And you can see that we initially ran BEAM with what the sort of average building that they would have built at Trent would have been, and that building would have had 211,000 tons of emissions. And using BEAM and helping them to select better low carbon materials, we actually got that building so that it instead is storing 6 tons of carbon. So that's a pretty huge difference. And these are the kinds of results that we'll be generating as part of this study. So we'll be able to say, well, this is what these buildings are, and this is where they could get to, and these are the things that would allow a building to get from a sort of high case scenario to a best case scenario. So in the final report, we'll characterize the Part 9 buildings from the GTA. We'll report on the material emissions quantity from all the sample plans that we gather. We're looking to study about 100 individual sets of plans and identify the largest contributors to the emissions, demonstrate the impacts of changes, and suggest changes to reduce emissions on all 4 of these levels, both at the material level, the building type, the energy efficiency, and the design. So, what of those 4 factors has the biggest impact, and what changes can be made in all 4 of those areas. And then we'll look at what it would take to reach 4 different thresholds. So a 25% reduction, a 50%, a 75%, and then a 100 or more % reduction in the material carbon footprint of the Part 9 buildings. So that's the full length of the presentation. That's what we have in mind. That's what we got funding from the Atmospheric Fund to undertake. And we are just getting that whole project up and running now. But I'm really happy to take any questions that anybody might have. And also, Eric Bowden is on the line, who is actually heading up the study. So if there are things that I can't answer, but Eric can, then he can jump in too.
Thank you, Chris. And hi, Eric. Just to ask people to we have 66 people here. So if people can type their questions, that'll be helpful. We'll get to as many as we can. Chris, what is your current favorite low carbon foundation option?
Well, I don't really want to pick favorites. I must say, there are lots of ways to do it, and it depends. Is it a shallow foundation? Is it a basement foundation? What are you trying to do? Is it an insulated foundation? We do use Nexem blocks, but we've also made our own foundations out of expanded glass. We have used earth bag foundations, but for this study, we will kind of be focusing on, well, what do people already do, and what are the sort of straightforward and cost competitive and available swaps. So my own bias towards alternative materials isn't really the direction that this study is going to be taking.
We also had a question whether or not the Ontario government was aware of the project and interested in it. I don't know if they're sort of formally aware of it, but different municipalities has been our focus.
Yeah, this has definitely been motivated by and from and for municipal governments. We've definitely found that even prior to this study, that's where almost all the interest in this topic has been coming from. And we'll definitely be inviting folks from the province, from Ministry of Environment, and but also housing, to see the results, and we'll definitely be sharing everything that comes out of this study with all levels of government.
Yeah, we're going to try to make the results of the study available in many different ways. So including discussion forum on the PBC website, and then video presentation with Chris. And if we're allowed to do in-person presentations, we'll do those. And so the results will be easily available. Chris, there was a question about the number in your presentation, 89,000 homes. Is that built per year?
Yeah, that was that was 20. I looked at 2019 because 2020 obviously was not a typical year for home building, but that was CMHC's number for single family homes across the country.
And the beam calculator, is it available for home builders?
It will be. We're working on that and should have a public facing version out this spring.
We had a question on who's doing the actual work on the study. The bulk of the work's being done by Eric, who's here with us. Yeah. And if you go to gallery view, you'd see him. Frank, I'm not sure I understand your question. A typical insulated home foundation. Maybe that's a reference to something else. Sorry if maybe you can swing back, Frank, and explain it to me. Are there any differences between buildings in the GTA and Muskoka? Oh, you're talking, yeah.
I'm guessing not. You know, everything that we'll be looking at is a Part 9 Ontario Building Code, you know, approved building. So there may be some differences in, you know, size, style, those sorts of things. But you know, we're hoping that by sort of encompassing the entire GTHA, that's going to include, you know, everything from single family homes in new subdivisions to some semi-rural things to urban infill and kind of everything in between. So I'm guessing that we're not going to see a huge difference between what we're studying and Part 9 buildings anywhere else in the province.
Do you have concerns about preserved wood foundations?
Yes, I do. And I think, you know, I'm seeing lots of very like material specific questions in the question box, which I sort of don't think this is maybe the right forum to get into, you know, what materials are better or worse than others. You know, there are lots of places, including PBC and Builders for Climate Action, where I'm happy to have those discussions, but I feel like we should probably stick to questions about the study here, because we could spend the rest of the day talking about the pluses and minuses of different materials here.
It's true. It's a great conversation. So we'll try to host more of those. But someone does ask about the negative rating of wood products in your evaluation, because does not any of the carbon return to the environment at the end of the building life?
Yes, it does. And that's a great question. One thing that I want to draw attention to there is that the negative numbers don't just come from wood. And in fact, wood is the most thorny of the biogenic materials to look at. But for the purposes of this study and for sort of climate, addressing the climate in general, the fact that that carbon is held out of the atmosphere for the lifespan of a building, which is, you know, people use all kinds of different numbers, but 50 years, 60 years is pretty typical in a life cycle assessment. If we look at the buildings around us, it's practically, you know, more like 100 or more years for the lifespan of a building. So while that carbon does end up back in the atmosphere at some point, and hopefully by the time we reach that point, we'll have figured out better things to do with it than just burn it or let it go back to the atmosphere. But even if it does, the difference between a material that has put emissions into the atmosphere when it was first made and a material that has pulled emissions out of the atmosphere over the lifespan of the building is massive, because the reason we're so interested in material emissions is they go into the air basically before your building is built, right? And once those emissions are there, they sort of drive the warming of the climate continuously, right? The emission doesn't go into the atmosphere today and it's gone tomorrow. It's there today, tomorrow, and for the next, 100 odd years, which means that for the whole time after you've made your building, that amount of emissions is in the atmosphere, pushing warming more and more. Whereas if your building, is a zero carbon building or even is even storing carbon, even if that's only for 60 years, the difference between having emissions in the atmosphere that are driving climate change for 60 years and not having them in the atmosphere at all until after 60 years is huge. It's, you know, it's what the IPC says we need to do. We need to get the carbon out of the atmosphere. And, you know, if we can reliably do that for at least 50 to 100 years, that's a really measurable impact on the climate and sort of what we need to be able to do in order to, if we're going to beat climate change.
And there was a question where to find more information on BEAM, and thank you, Frank, for putting the link there in the chat at Builders for Climate Action. Is there a difference in lower emissions and greater or lesser life cycle?
No, there's no direct correlation. So, you know, some materials which have really high upfront emissions might last longer, but some don't. There's certainly nothing that in our study that we wouldn't expect to last the length of an entire building's lifespan. So no, like, you know, the beyond the range of our study, like if we start looking past 50 years, there may be some differences, but, you know, again, if we're the climate crisis puts us in a very different position about how we think about these things. And we can't really say, well, in 100 years, this scenario might start looking better, because if we don't address it in the next 10, 20, 30 years, we won't really be caring whether, you know, material X or Y lasted, you know, an extra 20 years at the end of its lifespan. You know, we need to address this now, and we don't want to do it in a way where we're like cutting our feet out from underneath us, and these things won't work in 10 or 20 or 30 or 40 or 50 years. But, you know, we're including things in the study that we know will last the lifespan, the expected lifespan of a building. So, you know, if there's differences in lifespan beyond that, we're not really concerned about that.
Someone was asking about the timeline for the study completion. It will all be done this year. So, yeah. And then including release and hopefully some events around that. And then a couple of people have asked for more information on your slides and seeing your slides. There's a lot of stuff on Builders for Climate Action that relates to some of this. And there's going to be, and then there's a discussion forum on the PBC website that's going to contain the sort of just chatting about this. And we're recording this, and we'll kind of look to see what can be released and what looks good and how the recording comes out. Someone asked if there's an opportunity for grad students or internships around the study.
I'm not sure. Nothing right now. We'll see how the scope of work progresses and whether or not we're going to need any help once the study's really underway. But there's no immediate plans for that right now.
I'm trying to sort of pick out study questions here, but for the Trent U building, have you calculated the expected annual energy use in CO2 and compared the avoided embodied carbon against those annual expected emissions? Instead of taking X number of cars off the road is the equivalent of taking the default building offline for Y days.
Yeah, the Trent building is a you know, a really interesting example because it's also a net zero energy building. So it's kind of the best case scenario where it actually doesn't have any annual operating emissions either, and it's now net carbon storing. So like that's in fact a building that for its lifespan won't contribute to climate change at all.
We had, how do you relate the differences between scope 2 and scope 3 emissions compared to embodied carbon?
Well, we're not really addressing that. You know, the material emissions are pretty much all scope 3, which means that it's, well, that's getting into the weeds maybe a little bit, but scope 3 are emissions that a municipality or jurisdiction doesn't necessarily have direct control over. So, you know, the materials we're looking at, this one might be made in Manitoba, and this one might be made in New York State, and this one might be made in Ontario. We're not being specific about that. So we're not attributing only Ontario-made materials to these buildings. We're saying these emissions are being generated somewhere, and our municipalities have the opportunity to put into place policies that will reduce those emissions wherever they're happening. So this won't affect, if the GTHA municipalities decide we want to cut out embodied carbon emissions completely from buildings, it actually won't directly impact their climate goals, because a lot of the things that policy would impact aren't happening in the GTA. It's emissions that are happening, outside of that particular region. But emissions are also emissions, and our planet is one planet. And if our municipalities want to try to move towards zero emission buildings, it may not count in their own scope 2 calculations, but it matters to the planet that these however many 4 million tons of emissions a year stop happening. That benefits everybody.
Eric and Chris, will your study be keeping track of the amount of occupants in these different Part 9 buildings so we can reference back to embodied carbon storage per person?
That's a great question. That's, doing emissions per square meter is definitely a typical way of expressing that, but I think, there also is some real value to thinking about it as emissions per resident, especially in residential buildings. Obviously, we won't know how many actual people live in any building, but we will have, the actual plans for each building. So we'll know how many bedrooms there are. And I definitely see us, putting forward a number of different metrics, and emissions per bedroom or per occupant is definitely one of them that we'll be presenting.
Is there a consideration point where a higher carbon emitting materials that saves carbon from heating requirements becomes more feasible than a lower carbon option, which requires more energy for the building?
Well, I mean, our work so far sort of says that, well, really we're talking about insulation there, and there's a high emissions insulation and a low emissions insulation both provide insulation. So it's not like, well, I can only achieve building performance with this high emitting material. You can achieve the same building performance with any of those insulation materials. So what we're hoping the study does is sort of get people to look at, well, how do I get that win-win? How do I lower the operating impact of the building, which is still really important. Like, we're not in any way saying that's not critical. They're both critical. Like, buildings emit when their materials are made and when they operate. So if we're going to drive towards lower operating emissions, let's do it with low impact materials to start with, and then you kind of get the win-win. And if you go the other way, my initial report showed that if you make a really well insulated building with really high impact insulation, you might not see a net reduction in emissions for 30, 40, 50 years. So that's what we're hoping to really be able to point out and be more accurate with in this study, because we'll be looking at real buildings in a real climate.
A couple of folks are asking about costs or perceived costs of lower carbon materials, and will that be addressed, or if so, how?
It certainly won't be, really in our scope to address cost. Although, I know from my own practice and from, being in the industry a long time, that it's not like there's a direct correlation between cost and carbon footprint. In my initial study that I did, sometimes the lowest cost material in a category was also the lowest carbon footprint, and sometimes the highest one was the highest, or it could be the other way around. It's not really, we're not trying to set the market here. We're trying to, make it clear what types of materials and what types of strategies will make buildings have a low carbon footprint. And it's sort of then up to builders and designers and the marketplace to figure out, well, if this is important, how do we make that happen? But there's certainly nothing inherent in low carbon materials that makes them more expensive.
And have you tried, or will we try to incorporate circular building materials that have been retrieved from existing building elsewhere?
Well, we'll do that to whatever degree we find those things happening in the plans that we look at. And I'm guessing that may not happen at all, or it'll be a very small number of buildings, so certainly anybody who's doing material emissions calculations for a building, if you're using reused, recycled materials, that changes your numbers favorably. But I'm guessing sort of in the new home market, broadly speaking, in the GTHA, that's not something that's going to figure in heavily, but it is one of those things that really would make a big difference.
We had a question on where you go for a verifiable report on the carbon content for a specific design building, like a certifiable evaluation.
Well, it depends what the definition of certifiable is. The beam calculator is certainly, when it goes public, an attempt to do that. The Athena impact estimator, one-click LCA, like there are a number of life cycle assessment softwares out there. And ours in particular, Beam, uses environmental product declarations, which are like a third-party ISO standardized reporting mechanism for this. So, we feel like we're using the most solid and kind of reliable data that exists. And so, the numbers that we're generating, we feel are going to be as accurate as it's possible to be at this time.
And Living Building Challenge has, if you are looking for like a third party that actually does that for their certification, they do that for their certification to some extent. Someone's asking how long we think this might take before policy reflects the results of the research. It depends on how well we all organize, is what I would say.
That's right, yeah. I mean, certainly in some of the municipalities in the GTHA, there's already an appetite for it. So really, there are at least a couple municipalities that are like keenly awaiting this study so that they can insert some numbers and perhaps some thresholds right into their programs. And I'm hoping that we'll see pretty quick uptake. And there are cities outside the GTHA who are also really interested in and have already taken steps towards incentive programs like the kind that this report would help to sort of back up. So my hope is very quickly, those municipal officials are a central part of the audience for our report, and it's why TAF was interested in having us do this, because we were directly aiming it towards policymakers. So I would say that all the information that they're going to need to start making policy will be in this report. So then it'll be up to all of us to go let them know that this is something that we support and want to try to make happen.
And is Beam taking account the newer concretes that are coming out?
Yeah. I mean, we keep Beam really up to date. So the formulation for XPS insulation just changed, and we've got that in there. We also have spaces in the calculator for materials that we might not have found, or there might not have been an EPD when we made it, but you can there's user input areas so that new materials can end up in there. But yeah, it's our intent to keep it as absolutely current as possible.
We had a question regarding someone building a passive house and looking for a resource on where to choose materials and can they support the research somehow. I mean, there's the Healthy Building Network. There's the red list produced by the Living Building Challenge. And where else would which shows you what not to get.
Yeah, I would say, that on the Builders for Climate Action website, our white paper that we did, the sort of initial study that kind of kickstarted all of this, it's posted there for free. And that gives, a list of, which materials showed up in our worst case model, our mid-range model, and our best scenario model. And you could definitely use that to think about your own project. And, we're also at Builders for Climate Action, we'll consult with people on that. But I would say that white paper study is a pretty good place to start.
We're just at 12:56. Is there anything, Chris or Eric, that you want to sort of cover or say to people about it or the timeline?
I think just that we're really excited. I mean, just even this list of questions, the number of people that showed up today and the really great questions that are coming through make me really excited to be doing this. I feel like, you know, this isn't just something that a very small handful of us are interested in. I see like a sort of growing interest, and, you know, the kinds of questions that we're seeing here that start getting very specific. You know, I think that those questions, those debates, that conversation is really important, and I'm really glad to see so many people actually interested in engaging in that. And you know, we hope that this study really helps move that conversation along.
I'm going to sneak in one last one. The calculator have variations of materials such as cement stabilized rammed earth versus lime stabilized rammed earth.
To some degree, yes. So in our rammed earth right now, we have completely unstabilized. I think we have a 5% cement and an 8% cement content version. I don't think we have a lime stabilized one. In order to put these things in the calculator, we need verifiable numbers to back them up. So, you know, if there's a study that can show us a measurable difference between the two, then we will definitely include it. When we were scanning for rammed earth data about 2 months ago, there was nothing about lime stabilized, but, you know, to the greatest degree possible, we'll include all of those. And we're also, you know, always open to sort of figuring out custom calculations. You know, even if it's not coming from a verified EPD, you know, we can look at, you know, we have a rammed earth with no stabilizer. We have a lime footprint. I'm sure we could figure out how to put those together.
Great. Well, thank you, Chris. We're just going to wrap up because we try to always be on time here at PBC. Thank you for your time. Thank you, everybody, for coming. Builders for Climate Action. It's a very informative website. Passive Buildings Canada, we have a strong website with a good YouTube channel, which has a number of presentations, including one by Chris on embodied carbon that he did on a Boots on the Ground episode. So just look for Passive Buildings Canada on YouTube and look under, we have a playlist on embodied carbon, which includes a few presentations from Chris, including the keynote he did in Boston a year ago, Chris, maybe, at an energy forum. So thank you, everybody, for coming. We really appreciate it. And see you at the next one.
Okay, thanks all.